Good day, students. Welcome. We are now going to discuss the topic 3, which is entitled Hydrographic Positioning Methods. This is for the authors and contributors of this material, and here is for the copyright notice. For the intended learning outcomes, after this lecture and exercises, you, the students, must have first identified and described the various hydrographic positioning methods. Second is to perform computations related to hydrographic positioning methods such as eccentric station, resection, and other conventional techniques. For the outline of the presentation of this topic, we have three parts. The part 1 will be about eccentric station, part 2 will be resection, and for the part 3 is the other conventional techniques that involves triangulation and trilateration. Alright, so let's start our discussion with the horizontal positioning that involves eccentric station and resection. When we say positioning techniques, these two methods, the eccentric station and resection, is very important not only in the hydrographic surveying but in other kinds of survey. Alright, so let's start with the part 1, which is the eccentric station. So eccentric station is also known as satellite station, and the other term is false station. So it is being occupied when the true station cannot be accessed and if the view to the target station is being obstructed. No? So when gitawag siya eccentric station, it's because it's not the true station that you are going to observe. No? Murag nagbuhat lang kag another station for you to get the desired measurement that you are going to measure, no, to the target station. So here is the practical illustration on the eccentric station. So assume that you are here in this station, din mo giset up ang imong instrument, and you are going to get a measurement or information from this station to this station rather. But in this case, there is an obstruction which is a tree, no? So na ay nagharang sa iyang kahoy, di na to makuha dayon ang measurement to the target station. So we need to have a eccentric station here. So mo ni siya, which is tawag po siya tawag og pole station or satellite station. So nganong mo set up man ta diri, it's because we need to have another station for us to get the information that we desire to this target station. Kuhaon na to ang information from this station, then atong dadon sa ato ang satellite station or atong eccentric station, then atong ilabay sa padulong sa ato ang target nga station sa atong desired nga measurement. In computing the eccentric station, we need to use these two famous law, no, which is the cosine. First is the cosine law here, the cosine law which is going to use in computing the unknown side, no, this one in this case, and also the other one is the sine law, no, which is used to compute the angle needed for the azimuth computation. So basically, no, since kay dili man ta maka-occupy diri sa known station kay based on the previous slide that na atong gitan sa illustration, so naay possible na obstruction diri ang part mao nang di nato siya makuha directly. So we are going to use the eccentric station method or technique, no, which is mo-occupy na diri magbuhatag sa satellite station. Then out from that, we can get directly the given distance, no? Distance from this eccentric station to the first true station, and the other one is the distance, no, to the other true station using also the eccentric station. And beside from these two given distance nga directly na itong makuha out from this illustration, is we can also get this horizontal angle, no? So makuha na to siya directly sa using the instruments. And now out from this angle, so we have now two distances and one included angle, so makagamit na ta og cosine law to get the unknown distance. And out from the unknown distance, using the sine law to get the other side or the included angle. So, cosine law, sine law lang atong gamitan. So, let's have an example number 1. Due to the poor selection of traverse station, an eccentric station, which is named as station 10 prime, was occupied and the following data was recorded. So, station 10 prime to station 10. So, ang true nga station is station 10 and station 11, and the eccentric station is station 10 prime. So, station 10 prime to station 10, naa siya azimuth nga 315 degrees, 20 minutes, and 12 seconds. And a distance of 6.28 meters. And another data was station 10 prime to station 11, which is naa siya azimuth nga 237 degrees, and a distance of 15,307.56 meters. So the question is, find the azimuth and the distance from station 10 to 11. So may pangita, station 10 to 11. So to solve the problem number 1 is, first is we need to draw or to illustrate what is the problem look alike, no, kung ato siyang i-draw. So from this is natay given nga data. So by the way, natay duha ka true station, which is ang station 10 and si station 11. But due to poor nga sighting, which is di siya makita, na obstruction diri ang part, probably diri nga part. So they decided na to have a eccentric station which is named as 10 prime. So by the way, class, before na ko siya malimtan, si eccentric station is dili dapat na siya maglayo lang sa true station. So kumbaga murag gilihis lang siya, no, para lang yun makita na to ang target na station, no, para makakuha tag measurements. So out from the given data is we have the two given distances, which is from 10 prime to station 11 to be 15,307.56 meters, and we have also 10 prime to station 10 to be 6.28, and we have also azimuth given, which is the station 10 prime to station 10 to be 315 degrees, 20 minutes, and 12 seconds. And also station 10 prime to station 11 to be 237 degrees. And the question is, what is the azimuth of the station 10, station 10 to station 11? So mao ni ang gipangita. So sa tong nabuhaton, first is natay do ka given distances and makuha nato ni siya nga angle, no, si station angle 10 prime. So unsa man pagkuha kang angle 10 prime, so kani, no, so i-minus lang, no, ang azimuth 10 prime to station 10 minus angle station 10 prime to station 11 rather, no. So to visualize again, kanina lang atong dakan gamay yellow. So ang pagkuha ani nga part, no, diri kaning yellow is just this angle, no, kaning red, which is kani siyang 315, 20, and 12 minus, no, minus kaning angle, no, which is kaning 237 degrees. So itong i-minus, we can have the value of 78 degrees, 20 minutes, and 12 seconds. So mo ni karon ang angle na 10 prime, no? Ato siyang i-name as angle 10 prime. Then we have now the two distances, no, this one, and we have also the included angle na 10 prime. So natay two distances, one angle, one included angle, so we can now use the formula cosine law, no, cosine law. Let's recall cosine law is c squared, no, c squared is equals to a squared plus b squared minus 2ab cosine c. Sakto ba ko? I guess na-recall ninyo na siya. So ito yung substitute, si c diri ang part, c squared, which is ang isa ka side, no? Ang gi pangita, which is ang unknown, no? Si distance. So si c mo si c, then a magpili lang ta, it's either kani or kani, no? So we have here 10 to 11 squared, which is ang ato ang square ato anang c nga side, is equal to 10 prime to 10. So kani ang ato ang a, no? Kani si a, then kani si b na side. So minus of plus 10 station 10 prime to 11 squared minus 2 times angle A, side A, which is 10 prime to 10 times 10 prime to 11, no, which is nga to ang side B, cosine included angle nga C 10 prime. So kani siya ang atong included angle. So substitute the value, no, c squared, no, which is 10 minus 11 squared is equals to a 6.28 meters squared plus b na to nga 15,307.56 squared minus 2 times a nga 6.28 times b nga 15,307.56 cosine included angle nga 78 degrees 20 minutes and 12 seconds. So we can have the value of 15,306.292 meters, no? So mo ni karon si value sa c, which is ang atong unknown distance. So since we have now the three distances of the side of the triangle, so diri nga part, diri and diri, so ABC na natay side na natay measurement. Then we have also the included angle or the angle 10 prime, which is kani. So we can now get the other interior angles, namely the angle 11 and angle 10, para makuha na to ang azimuth na 10 to 11 or azimuth station 10 to 11. So kani nga angle. So makuha na to na siya using the angle nga given sa ato ang angle 10. No? Ato naman i-add, no, para makakuha ta og azimuth. So we are going to use now the sine law, no, which is used to compute the angle needed for the azimuth computation. So sine law, using sine law, so we have now the equation sine angle 11. So kani opposite niya is ang 6.28 meters is equal to sine 10 prime, which is given, no, kani 78, 20 and 12, over the opposite side, which is ang nakuha nato nga distance ganina, which is 15,306.2.2 meters. So out from that, we can have the value of sine 11, or rather angle 11 to be 0 degrees 01 minute 22.88 seconds. So natay angle 11. And we need also to compute, no, the angle 10. Compute or to solve for that is just 180 degrees minus angle 10 prime minus angle 11. So substitute the value, 180 degrees minus 78, 20, 12 minus 0 degrees, 1 minute 22.88 seconds. So we can have the value now for angle 10 to be 101 degrees 38 minutes, rather 25.12 seconds. So next is to compute the azimuth, no, from station 10 to 11. Station 10 to 11, no, from this formula, no, or from this illustration rather, is from south padulong dito. And para makuha nato na siya is we need to use this equation. Since kailan naman tayo angle 10, no? Kaning green, na siya si angle 10, and we need to get this value, kaning value of this angle, kaning part, which is equal na siya sa kani, no? Para makuha nato na siyang angle, we need to calculate, no? Or itong i-visualize nga, full rotation is 360 minus kaning red, para makuha nato ni nga angle. So to get that is just 360 degrees minus 315 degrees, 20 minutes and 12 seconds, which is ang kaning red. Mo na siya si 315 degrees, 20 and 12 seconds. So to calculate the azimuth from station 10 to 11 is just 180 degrees, no? Atong i-visualize, no? 180 degrees kani minus kani nga angle, which is equal na siya sa katong ikuha na to nga 360 degrees minus 315 degrees, 20 minutes and 12 seconds. So ang mabili na lang is ang kaning diri nga part, no? And since ang atong azimuth is padulong man sa 11, so i-add na lang nato ni si angle 10. So substitute the value, we can have the azimuth to be 135 degrees, 20 minutes and 12 seconds, which is ang difference ani niya, no? So mo ni iyang value. Then i-add nato ang angle 10, which is 101 degrees, 38 minutes, 25.12 seconds. So we have now the azimuth to be 236 degrees, 58 minutes, and 37.12 seconds. So muna itong final answer. So much for the part 1 or the eccentric station method. Let's go to the part 2, which is the resection. When you say resection, it is the sighting, no, of the horizontal angle of 3 known points from an unknown point. And resection usually used in bathymetric survey where the measurement of distance is being impossible. It's because na naman sa dagat, no? Lisod na siya kuhaan og distances from water, no? So basically the illustration of the resection is say for instance, this is the shoreline from the sea and the land that separates the sea and the land, and the nga part is oceans na or sea na siya nga part, no? And diriya is ang land sa babaw. So ang pasabot niya class is there is a 3 known points daw from, of course when we say known points and fixed points, dapat naa siya sa land, no? Parang dili siya malihok-lihok. So, say for instance na itulo dira ka points, no, sa land, and ikaw na hydrographer or doing the hydrographic survey is nakadri sa sea, no, sakay ka sa bangka, diri nga part, sakay kag bangka, sakay kag baruto, and you need to get the location of this point, no, kung asa ka nag observe. So you're going to use these 3 known points from the coastline, no? So imo na siyang readingan diha, no? Readingan po nimo diri and also diri. Kaya mga fixed points ma siya, you're going to use the information from the fixed points, no, or known points from the coastal areas to get the location or what is the desired measurement na imong gusto sa imuhang gi-occupyan kung asa ka nag-observe sa imuhang instrument. And also, these 3 points have also their relationship, and those relationship nga kung unsay naa sa ilaha nung pwede na to siya magamit for you to get the desired measurement na imong gusto. So you can use that, no? So like for example, naa siya distance from this first fixed point to second fixed point, and second fixed point to third fixed point. So makuha na nila siya. And now we can have the information nga imong desired sa kaning point, no? Like for example, gusto ni mahibawaan niya from fixed station 3 padulong sa imuhang station observe, no? Pwede mo na siya makuha. Then kani is ang station 2 padulong sa imuha kung asa ka nag-observe, pwede po dito siya makuha. So as sa station number 1. So nga na ang pasabot sa resection. And resection, no, we need to identify a suitable device, no, for measuring horizontal and vertical angles. So since dili man siya aluhag man jud kayo, no, pag if ever we are going to measure distances, no, from both into the shoreline, which is the 3 fixed points. So we need to determine what is the suitable device that we are going to use. No, it's because the measurement of the resection is maybe not stationary, okay? Dili man siya kanang parehas jud na, like for example from the effects of the tides and the currents of the oceans, no, maka-affect siya sa atoang pag measure. And also in this section, it's not for small angles and small distances, no. Usually lagyo gid na siya, no? Kay mas kung if you're going to sight or if you're going to observe distances from afar, so dili na kay siya luhag compared sa katong mas duol nga gamay lang na effects of the currents and tides. Dako na kay siya nga discrepancy, no? While kung lagyo, no, mas more stationary na siya, no? Ang imuhang measurement kay lagyo naman siya. So this is the instrument that was used, no, in measuring distances in resection method. So kani siya nga equipment is equipped siya to get the horizontal angles, no, from the horizon, and also mukuha pod siya og vertical angles. So ang tawag ana niyang instrument is sextant. No, usually ginagamit pod ni siya sa mga sea navigators, no, mga seaman, no, all persons na nag trabaho in the sea or navigation. They are using that equipment to get the angles, no, from the shorelines, nga ilahang padulngan, no. Or also they have used that for estimating on where are they right now, no, kung nasa sila sa sea. So that's what we call sextant. So here's another illustration on sextant, no, and how it works, no, and how this instrument is being used. If you're going to look, no, in this part, no, which is the telescope mga part, so kani mo makita, no. So there's an horizon, no, out from that horizon you can get the vertical angles, no, up there, and also the horizon vertical angles diri nga part. Then you can also get, no, the horizontal by using the kung asa ang north, asa ang south, no, kung asa nimo siya gi project, no. It uses light, no, para makita nimo diri sa telescope, no. Tinga na ang how sextant is being utilized. These are the methods of how to solve a resection. First is we have Kästner-Borchardt method, Collins method, Cassini method, and Jenstra method. But since those methods are being complicated, no, in solving on how to solve a resection, so here is the popular one. Though wala siya nakapangalan kung kinsa siya, but geodetic engineers name it as the ACS method. It's because this formula is being utilized, no, on solving, no, on how to solve a resection method. So the ACS method, what they say ACS method is came from the derivation of the formula, no, out from the figure of the resection. So the goal of this one is to compute the theta and the lambda, no. The important part here in the solving resection class is you need to familiarize what is the figure, no, and also the placement of the variables, no. So pag resection ganing, no, you need to memorize that the theta is always on the left side, and lambda, no, but again, theta is in the left side and lambda is the right side. No. And also, alpha is in the left side and beta is in the right side. So, ako sa una, no, during pag memorize na ko ano nga formula is para dili na ako siya matiman-an, mag-uban dapat siya ang vowels, no. Murag ako siyang gihimuog, gigroup na ko siya, no. Since theta is mura siya og letter O, so ako siyang partner man niya si alpha, which is letter A, no. So dapat mag-uban na si alpha og si omega, no. So si alpha and si theta rather, mag-uban dapat na sila, and si lambda, which represents for me, para dali na ako siya remember, is letter Y, no? Baliho na ako siya, letter Y. Uban dapat na sila ni beta, no? And we have also their AB and BC, no? So we're going to use the theta and or the lambda, so kani and kani, no, to compute, no, the distance of the side AO, no, BO, CO, and also their respective azimuth. Okay, since si AB and BC is known mo na siya, no, kuha mo na siya, it's because point ABC is mo na siya ang katong 3 fixed points, and ang kaning CO is ang katong unknown point, no, which is atong kuhaan og desired measurements, no. Yan na siya. So ang importante part diri sa pag-solve sa resection is ang pag-familiarize sa figure, no. So let's now derive the formula for the what they call easiest method. So we have here the figure, no. Again, palikod dyan ako. Very important in solving the intersection method is on the familiarization of the figure, on how it looks like, no, ang pag-solve sa resection. So again, always, no, on the left side is the vowel and the right side is the consonant, no? So vowel na si omega, si theta and si alpha, and also si lambda and si beta mag-uban, no? First is we need to compute the BO using the triangle ABO. Triangle ABO, no? So using we need to compute the, no, BO, no? So using sine law, no, BO, which is si BO over ang iyahang angle is si theta, so over sine theta is equal to known side si AB, no? AB, then iyahang opposite angle is si sine alpha. So another one, no, is we need to compute also the BO, no, which is si BO man, side BO man ang ilahang common, no, sa two triangles. So we need to compute again BO, no, using another triangle, which is the triangle BCO. So sine law, BO, no, BO opposite angle lambda over sine lambda is equals to BC, which is given, and opposite angle beta. So we have now these two equations, no, na atong nakuha from the two triangles, which is BO over sine theta is equals to AB sine theta over sine alpha, and the second equation is BO over sine lambda is equals to BC sine lambda over sine beta. Next is we need to combine these two equations, no, in terms of BO, okay, since we have the same, no, or we have a common side, which is BO. So in terms of BO, we can now have this equation, no, AB sine theta over sine alpha is equal to BC sine lambda over sine beta. But we're going to let, no, si theta plus lambda to be R, no. So later on ito na i-discuss kung asa ni si R, no, kung saan pagkuha sa R. And no, by mathematical manipulation, we can have lambda to be R minus theta. Then we are going to substitute this r minus theta, no, kay para ang atong equation is in terms of theta, no. So ato ning i-substitute ni si r minus theta, no, diri sa atong equation diri sa lambda part, no, diri sa lambda. So we can now have AB sine theta over sine alpha is equal to BC sine r minus theta over sine beta. Next is we're going to recall, no, the sign of the difference of two angles. No, diba? As we remember in our trigonometry, no, nga pag sine A minus B is may mo siyang sin cos sin, no. Tapos kung unsay sine nga naa sa sulod, kung minus siya, so minus pud ang sign niya. So same goes, no, sa ato ang sine r minus theta. So we have sine r times cosine theta minus cosine r sine theta. So mo na itong gamiton karon to substitute this identity into this one, nga equation. After we have substituted, no, the identity of the sign of the difference of two angles into our last equation, we can now have this AB sine theta all over sine alpha, that is also equal to BC sine r cosine theta minus cosine r sine theta all over sine beta. Next thing is we need to interchange, no, sine theta and sine beta. Kaning si sine theta, kung ibalhin din sa ubos, din si sine beta sa taas. So we can now have this AB sine beta all over sine alpha, BC sine r cosine theta minus cosine r sine theta all over sine theta rather. But we can cancel this cosine theta all over sine theta, or ato siya i-convert. So cosine over sine, we can now have this. Di ba no? Cosine over sine is equal to cotangent. Muna siya si cotangent na siya. Then we can also cancel sine theta and sine theta. So out from that, no, we can now have the equation AB sine beta all over BC, no? Yan si BC, ato siyang ibutang diri sa ubos, sa ibaba. So BC sine alpha, no? BC sine alpha, that is equal to sine r, no? Sine r cotangent, no, kaya ang kaning cosine over sine ay mo siyang cotangent theta minus cosine r, kaya makancel naman si sine theta, no? Then we need to divide the whole equation into sine r, no, sine r, para makancel ni si sine r, no? So if we are going to divide, no, the whole equation into sine r, we can now have this equation, no, AB sine beta all over BC sine alpha. So kag i-divide mo na to siya, duwa na to siya og sine r is equal to cotangent, no, cotangent na mabilin kay makancel ni si sine r, no, cotangent na lang, cotangent theta minus cosine r over sine r, no? Again, cosine over sine is also cotangent. So we can now have cotangent theta minus cotangent r. So since we have now this equation, no, in the previous slide, so we need to express this in terms of theta, no? So out from that, no, we can have cotangent theta is equal to AB sine beta over BC sine alpha sine r plus cotangent r. So again, ang kani siya nga equation, from this equation gikan na siya diri sa taas, no? Gikan na siya diha, plus star lang siya. Also, we can express this one in terms of lambda, no? Using katong relationship between r is equals to theta plus lambda, diba, no? So out from this one, no, out from this equation, pwede po siya in anig forma, no? Cotangent lambda is equals to BC sine alpha over AB sine beta sine r plus cotangent r. No? Again, gibaylo lang na siya. No? Ako lang explain sa inyo later on saan siya pag-memorize nga mas dali. No? So this is how we are going to memorize, no, the equation, the formula for resection, no. So again and again, ako balik-balikon, in solving resection, we need to familiarize first the forma, no, unsay forma sa resection. Kung asa nabutang ang mga variables, no, kung asa nabutang si lambda, asa nabutang si theta, si alpha, si beta, and so on and so forth. So, pradali na ito siya memorize, no? So, using this formula, cotangent theta, no? That is equal to AB. So, first is AB, no? Kung aha nabutang si theta, moto siya ang first na side, no? Naibutang diri. So, kung nabutang din si theta, no? Kung cotangent theta itong gamiton, AB, no? AB sin beta, no? Mag-cross, no? AB sin beta, no, all over the other side, which is BC, no, cross na po sa pikas, which is sin alpha. Dugangan lang na to siya og sin r plus cotangent r. So yan na ang formula, no. Now kung kato na pong cotangent itong gamiton, no, formula is cotangent theta, diba? Cotangent lambda rather is equal to, no, kaya naaman diri si lambda, so ato na pong gamiton nga side is si BC, BC sin opposite, na ang iyahang opposite, which is sin alpha, no, all over sunod opposite side AB, AB sin opposite, no, beta, then dugangan na to siya og sin r plus dayon cotangent r. So yan na ang pag-derive sa formula. So depende na sa to kung atong gamiton, no? So si cotangent theta ba or si cotangent lambda, no? So yan na pag-memorize sa formula. From this formula, no, cotangent theta is equal to AB sin beta all over BC sin alpha sin r, no, sin r plus cotangent r. So we have this variable r. No? Okay. Out from the given, no, from in any problem, no, sa resection, usually given is si AB and BC, which is distances na siya from the known points, no? And also si alpha and beta is also given. The question there is unsa na to pagkuha sa value aning r, no? Aning r mao ni ang pinaka crucial nga part kung unsa na to siya pag-determine, no? And also how to kung naamang galing hint, so unsa tong buhaton para makuha nato ang value sa r. In computation of r, let's go back to this figure, no? So na si AB, BC, alpha, beta, theta, and lambda, no? So we all know that the sum of the interior angle of a quadrilateral is 360 degrees. So that's why we have 360 there, no? And we all know as for the figure, no, mato makita diri is we have theta plus lambda plus alpha plus beta plus this angle, no? Let us say that this is angle ABC, no? So that is equal to 360 degrees. And we all know that we let the r, no? So itong kaganina before aning mga slide, we denote that r is equals to theta plus lambda. So we are going to substitute, no, or substitute theta plus lambda to be r. So therefore mahimo na ni siya from this equation, mahimo na siyang ingani, no? Since theta plus lambda is r, so 1 si r, plus alpha plus beta plus the angle ABC is now equal to 360 degrees. So ito siyang in terms of r, we can now have 360 degrees minus alpha minus beta minus angle ABC. So the problem now is unsa no to pagkuha ni si angle ABC. So to compute the angle ABC from the given azimuth, no? So based ani sa ato ang figure, no, which is came from the previous na figure sa slides, no? So we can say that we have azimuth AB kaning violet, and azimuth BC. Now, so we are going to get this angle. So this one, kaning blue. So this angle is equal to azimuth AB, no, AB minus 180 degrees. Kaya kanira man yung angle. Azimuth AB minus 180 degrees is equal to this one, which is this angle, no, is also equal to this one. No, diri nga part. Equal na sila. And we have also there azimuth BC. No? And azimuth BC, we need to get this angle, no, para makompleto na to ang angle ABC. So this angle is equal to 360 degrees, which is the full rotation, minus the azimuth BC. So ang mabilin is kani nga angle. So kani nga angle is 360 minus azimuth BC. Now to have the triangle ABC kaning tanan, no, kani tanan, pagkuha na niya is the azimuth AB minus 180 degrees, which is equal to this one, plus 360 minus azimuth BC, which is also equal to this one. Pag ato na siyang i-add, we can now have this angle ABC. So nga na pagkuha sa angle ABC. Example only. If given na we have these two azimuth. But again, it depends on the problem na kung unsay ihatag nga given. So this is the important note, no? That if you are going to calculate, no, the resection using the theta, no, or in terms of theta, and if the computed value is negative, no, negative, then you need to use the another formula, which is in terms of lambda, no? Same lagi hapon katong kaganina, di ba? Duha to ang formula in terms of theta and in terms of lambda. Now, if you get the value, if you get a negative value, no, or negative answer using the theta, no, then use the other one, no, which is the lambda. So again, if your computed theta is negative, compute the lambda using the cotangent formula, then compute theta using the relationship between r, theta, and lambda. So inga na lang siya, no? Kung negative, katong isa ka formula ang gamitan. So let's have an example, no? In the figure shown, no, the stations A, B, and C are observed from P, whose known data are angle BAC, which is 102 degrees and 45 minutes, angle BPA 26 degrees 35 minutes, angle APC 44 degrees and 15 minutes, and we have the distances AC, which is 6,800 meters, and AB to be 6,600 meters. Now, we need to find the angle ABP and angle ACP, and also the distance BP. So this is now the figure. Now, we have the given angle BAC, which is this one, BAC to be 102 degrees and 45 minutes, and also we have given BPA, so BPA, which is this one, to be 26 degrees and 35 minutes. Another given, which is the angle APC, this one, we have 44 degrees and 15 minutes. We have also given AB, which is 6,600 meters, and AC to be 6,800. Now, mo na akong gingon na we need to familiarize on the placement of the variables. Again, on the left side is the vowel, which is alpha, and the theta. No? So, na si theta, na si alpha. And on the right side is the consonant, which is the beta and the lambda. So now, going back to our equation, which is we're going to get the theta, no, using cotangent formula. So we have cotangent theta is equals to AB, AB kaning part, so or AB or BA, then cross, which is sine beta, all over AC, ang kaatbang niya nga side, no? AC, then cross na pod sine alpha, then dugangan ra siya og sine R, and plus cotangent R. Substitute the values, no? We have now cotangent theta is equals to 6,600 sine beta, which is 44 degrees 15 minutes, all over 6,800 sine, ang alpha na to is 26 degrees and 35 minutes, and we have sine R and cotangent R. So we all know that R is equals to theta plus lambda. And now we are going to get now the value of this R. Now, so again, using the formula, which is the sum of all the interior angles must be 360. So we have theta plus lambda plus alpha plus beta, and this angle, no, kani siyang kaning green, which is the angle BAC, pero sa baliktad niya, sa luyo nga part, luyo, no. But to get this angle kani naka green is kaning violet nga part, no, is just 360 degrees minus angle BAC. Given na to ang BAC 102. So we're going to substitute or replace rather the theta plus lambda to R, no, plus value of alpha, which is 44 degrees 15 minutes, plus the beta to be 26 degrees and 35 minutes, plus 360 degrees minus 102 degrees and 45 minutes. And now, so ato siyang i-equate into 360 degrees, and nanan na nabilin nga variable which is ang R. So we have now R is equals to 360 degrees minus 44 degrees 15 minutes minus 26 degrees 35 minutes minus 257 and 15 minutes. So we have now the value of R to be 31 degrees and 55 minutes. So we have now the value of R to be 31 degrees and 55 minutes. Then let's substitute this value to the R, to the formula. So we can have now cotangent theta is equals to 6,600 sine 44 degrees and 15 minutes all over 6,800 sine 26 degrees 35 minutes sine 31 degrees 55 minutes plus cotangent R, which is 31 degrees and 55 minutes. So out from this formula, we can have the value of theta to be 12 degrees, 36 minutes, and 54.54 seconds. So, nanatay value sa theta. And you are going to get now the lambda out from this relationship, which is R is equals to theta plus lambda. So, natay R, we have also theta, we can now get the value for lambda. So, lambda is equals to R minus theta. So, substitute the value to be 31 degrees, 55 minutes minus 12 degrees, 36 minutes, 54.54 seconds. So, we can have now the value of lambda to be 19 degrees, 18 minutes, 05.46 seconds. Which is ang gipangita sa to ang problem is ang angle ABP. ABP is also equal to the theta, no? And also the angle ACP, which is also equal to the value of lambda. So we can now have the answer for the problem. No? And lastly is we need to get the side BP. No? Can you see? Side BP and naka-red. And out from that, we can use the sine law, no? Which is BP, ang atong gipangita, all over opposite angle. No? Opposite angle, so nanatay theta, naapod tay alpha, bali man ni siya, na alpha man ni. So, we can have the value for this opposite no sa side ng atong gipangita. So, to get that angle is just equal to 180 degrees, no? Since 180 degrees is the sum of the interior angle for triangles, no? 180 minus lambda, which is given, and also angle BPA, which is also the alpha, no? So ang mabilin sa 180 is ang kaning angle na BAP, no? Which is ang opposite sa side nga atong gipangita, side BP. And we have also AB, no, which is given siya na 6,600, no? Over sine BPA, no? or the sine alpha. Substitute, no? You can have this equation, BP over sine 140 degrees, 48 minutes and 05.46 seconds. So mo ni siya ang value, no, out from this equation sa taas. And 6,600 all over sine alpha to be 26 degrees and 35 minutes. So we can now have the value for BP to be 9,321.268 meters. So mo ni atong answer karon sa katulong gipangitaan niya problem. Alright, so this ends our video lecture, and I hope class that this video lecture will help you in understanding and understanding the subject, which is the hydrography. And if you have any questions and clarification about this topic, you may drop your message in my FB page, no, so that I can answer it directly, no. And again, thank you so much for watching, and keep safe everyone, and have a good day.